Let's consider some specific Mo programs and decide whether they should pass the type checker. So in this case, we've got posin with x and y fields, each of which are integers. It extends object, which is good since object is predefined. Mdist takes an integer and returns an integer. That's all good. This dot x, x exists, but it is not not an object. It is a number. So this should fail, and then similarly for y because they're not objects. All right, this one's almost the same all the way through. We've got this dot x, that is good. X really does exist on this, which is a posin. But now we have this dot z. Oh, that should fail also. So again, the type checker will complain before we even run the program that posin has no z field. What if we call get y? Well, similar to trying to use z, there is no get y method, and so that should fail. What if we say this dot y? That's all good. And so now I have this dot x. X exists as an integer. Y exists as an integer. We can add them and get an integer. But the result type now is declared as posin. That's not consistent, so this should fail. All right, the type checker should complain that the body does not match the declared result type for the mdist method. How about now? I've changed the declared result type to be integer. All the other parts are the same. So yes, that one should pass the type checker. What if we say new posin 12 here, right? Notice that we weren't even creating the object that, of a class that had trouble before, but now we are creating an object. But if you see I passed just one argument, 12, and posin has two fields, so that should fail. Now I have posin with two fields and another posin with two fields nested. This one is okay because 1 and 2 both have type int, but new posin has type posin, which is not an int, so that outer new posin will fail. Okay, now I got new posin 1, 2, that lines up, and I'm going to call the clone method. Clone exists. It expects an argument that's an integer. I'm passing in 0. That is all good. We return a posin, and we say new posin with this x and this y. X exists in this as an int, y exists as an int. That all looks good. That should pass the type checker. What if we make a subclass, posin3d? So I haven't changed posin. Since I haven't changed anything here, we expect posin to still be okay. Posin3d extends posin. Posin is declared. We add an mdist method. Nothing wrong with that. It takes an argument that's an integer, returns an integer. We do this dot z. This time z does exist. Here I have a supercall to mdist. Does mdist exist in the superclass? It does, so that makes sense. And we get an integer back. All of this looks fine, so yes, that should pass the type checker. But what are some things that could go wrong? Maybe we declare that the result is a posin and we return a posin. Locally this is okay, but this overriding method mdist changed the result type. And so if you have a posin3d but you think you have a posin and you call mdist, the wrong kind of result will be produced. And so the type checker has to rule that out. Specifically, the type checker has to insist that when you override a method, you keep the result type the same, as well as the argument types. Okay, what if we then go back to our mdist that was okay, and I add a clone method that is returning integer instead of posin? Same deal here. We clone changed the result type, so that's not okay. So now I've changed the result type of clone to be posin, just like it was in the superclass method, but I'm returning a posin3d. This posin3d construction is just fine. Can I produce a posin3d where posin was expected? Well, it depends on how we check things here. So we do want this to work. This is a sensible program because even if you think you have a posin and you clone it, you do get a posin back. It just happens to be more specifically a posin3d. So this alerts us to the fact that we will need a notion of subtypes and that method bodies will need to have a type that is the same or a subtype of the declared result type. So overall, we need to make sure that anytime we use a name as a type, that it's a declared class name. We need to check that when you access a field or call a method, that field or method exists in the relevant class, where the relevant class is determined by the type of the left-hand side of the dot. And then we need to check that the types, that you passed a method or get back from a field, that those are consistent. We will need to make sure that when you use new on a class, you provide the right number and type of arguments. check that overrides are consistent, and we will need a notion of subtyping, and subclasses should count as subtypes.